Welcome. If you're joining us today, you are probably someone who loves learning.
Yeah, someone who's insanely curious.
Exactly. You're someone who wants to understand the big ideas shaping our world without, getting completely bogged down in technical jargon.
Which is exactly what we're doing today.
Right. Welcome to this deep dive. Our mission for this session is simple. We are going back to basics to provide a completely beginner-friendly, jargon-free overview of a technology you've absolutely heard of, but, well, maybe might not fully understand. We are talking about blockchain.
It's a topic that carries a lot of hype, a lot of mystery, and frankly, a massive amount of confusion.
Oh, absolutely.
But we've been digging through a huge stack of material for you today. We're talking everything from dense technical guides and historical articles to comprehensive white paper breakdowns and industry surveys, basically synthesizing exactly what you need to know.
And right off the bat, we have to address the elephant in the room. When most people hear the word blockchain, they immediately, almost reflexively think of Bitcoin.
Right? The crypto bros.
Yeah, they think of cryptocurrency, finance trading, those wild charts with the red and green candles. But as we're going to explore today, equating those two things is a huge misconception.
It really is. Treating blockchain and Bitcoin as the exact same thing is a lot like saying the internet and email are the exact same thing.
Oh, that's a great way to put it.
Yeah, because email was just one of the first major applications built on top of the internet. In that same vein, Bitcoin is simply the first and most famous application built on top of blockchain technology.
The underlying architecture itself is actually much older, right?
Vastly older, and its potential applications are so much more expansive than just digital money.
Okay, so to get us started, let's strip away the crypto layer entirely. Let's look at the absolute core concept. What actually is a blockchain? While I was reading through the notes for today, I found this brilliant analogy that makes the whole thing so much easier to grasp. I want you to imagine a Google Doc.
Okay, Google Doc.
Yeah. You know how you can share a link to a Google Doc and thousands of people can open it up and read it simultaneously?
Right. Everyone is looking at the exact same version of the document, live, at the exact same time. It's a shared state of information.
Exactly. But here is the twist. Imagine that this specific Google Doc is set up so that absolutely no single person has administrative control over it.
Nobody at all.
Not the person who created it, not the users, not even Google. You can add a new line of text to the bottom of the document, but once you type it and hit enter, you can never edit it, and you can never delete it.
Wow.
Every single change ever made is permanently recorded chronologically, and everyone looking at the document can see that entire history. That, in its simplest essence, is a blockchain. It's a digital ledger.
That analogy perfectly captures the three fundamental traits of a blockchain. First, it's distributed and decentralized.
I mean, it's everywhere.
Right. Instead of one central server like a traditional bank holding all the financial records in a private database, copies of this ledger exist on thousands of computers. We call these nodes, and they're spread all over the world. No single authority controls the document.
And the second trait?
Second, it's immutable. Like you said, once data is written into a block and added to the chain, it cannot be changed retroactively without altering every single block that comes after it.
Which is basically impossible.
Exactly. And third, it's transparent. Anyone participating in the network can view the complete, unedited history of transactions.
Which brings us to a phrase that gets thrown around constantly in this space, a trustless system. Now, I have to be honest, to a beginner, trustless sounds terrible.
It sounds like a scam.
It sounds like a system you fundamentally cannot trust. If I don't trust it, why on earth would I put my data or my money into it? And furthermore, somebody still writes the code, right? What if the code has a bug? Can we really trust it 100%?
What's fascinating here is that trustless actually means the exact opposite of how it sounds. It doesn't mean the system is unreliable. It means you don't need to trust any individual human middleman.
Okay, tell me more about that.
Let's think about the traditional world. If you send money to a friend, you have to trust your bank to deduct the funds from your account, and you have to trust their bank to add those funds to their account. You are relying on a centralized human institution.
And humans make mistakes.
They make errors, they can freeze your account, or they can get hacked. In a blockchain, you don't need to trust a bank, a corporation, or even the person you are transacting with. You only need to trust the cryptography.
So the math is the middleman.
Precisely. The cryptographic code enforces the rules automatically across thousands of independent computers. As for bugs in the code, that is a real risk in newer applications, which is why the core layers of these major blockchains are open source.
Meaning anyone can look at it.
Yeah, thousands of the best cryptographers in the world constantly audit the code. You aren't blindly trusting a closed-door corporation. You are trusting verifiable, open mathematics.
Okay, let's unpack this history, because I was totally wrong about when all of this started. If you had asked me yesterday when blockchain was invented, I would have confidently guessed somewhere around 2008 or 2009 with the invention of Bitcoin.
Most people would.
But looking at the historical articles we gathered, this concept was actually conceptualized way back in 1991.
That's right. It predates digital currency by nearly 2 decades. Two research scientists named Stuart Haber and W. Scott Stornetta were trying to solve a very specific pre-digital currency problem.
What were they trying to do?
They wanted a way to timestamp digital documents so that those documents could not be backdated or tampered with. Think about the implications for proving intellectual property or securing audit logs. If I write a script, how do we prove I wrote it on a Tuesday and not 2 years later?
Oh, that makes total sense.
So they published a paper outlining how information blocks could be cryptographically secured and chained together to create an unalterable timeline.
And what blew my mind in the research is that they didn't just write a theoretical paper. They actually put this into practice. The world's oldest running blockchain has been hiding in plain sight since 1995.
Yes, it's one of my favorite stories in the tech world. It's not running on some supercomputer in a secret underground bunker. It's literally in the newspaper.
It's so crazy.
Haber and Stornetta founded a company called Surety. Every single week they take the cryptographic hashes, which are essentially the unique digital fingerprints of all their clients' document certificates for that week, and they publish that string of text in the classified section of the New York Times.
That is wild. They use a physical newspaper as a decentralized network.
It's a brilliant analog solution to a digital problem. By printing the hash in a widely distributed physical newspaper, they prove the existence of that data at that specific point in time.
Because you can't fake a million newspapers.
Exactly. You can't hack the New York Times archives and change a physical newspaper sitting in a million different libraries. But of course, the technology really took its modern, fully digital form in 2008 when the mysterious Satoshi Nakamoto published the famous Bitcoin white paper.
Right, the infamous Satoshi Nakamoto. To this day, nobody knows if it's a single person, a group of developers, a government agency, or who is behind the pseudonym.
Still a total mystery.
But the white paper they published, titled Bitcoin, a peer-to-peer electronic cash system, took that 1991 concept and solved a massive hurdle in digital finance called the double spending problem. How exactly did that work? Why couldn't we just have digital peer-to-peer cash in, say, 1999?
The double spending problem is the core reason we've always needed banks for digital money. Think about it this way. If I hand you a physical $20 bill, I no longer have it.
Right, I'm holding it now.
The physics of the real world prevent me from spending it twice. But if I send you a digital file like an MP3 or a photograph, I might still have a copy of it on my desktop. I could send that same MP3 to 50 different people.
So before Bitcoin, there was no way to prove someone didn't just copy and paste their digital money.
Not without a central bank sitting in the middle verifying a private ledger. No. Nakamoto's genius was combining Haber and Stornetta's cryptographically chained blocks with a peer-to-peer network consensus mechanism.
So instead of one bank checking the ledger, thousands of computers check the ledger simultaneously to make sure you didn't just copy-paste the money.
Exactly. And that system officially went live on January 3, 2009. Satoshi Nakamoto mined the very first block of the Bitcoin blockchain, which is known as the Genesis block, and received a reward of 50 Bitcoin for doing so.
But there was a message hidden in it, right?
Yes. What's truly poetic is the secret message Nakamoto embedded in the raw code of that Genesis block. It was a headline from that day's edition of the Times of London. It read, "The Times 03 Jan 2009 Chancellor on brink of second bailout for banks."
Wow. So it wasn't just a tech experiment. It was a very clear, pointed critique of the traditional centralized financial system, a system that was actively collapsing during the 2008 financial crisis.
It perfectly encapsulated the motivation behind creating a decentralized alternative. It was a statement that we needed a system that didn't rely on fragile human institutions.
It's such an incredible origin story, but I want to bring it back to the practical level for you listening right now. We know it's a chain of blocks. We know it's a shared Google Doc. We know it's secure. But how does a transaction actually happen?
like under the hood.
Yeah. If I want to send you something on a blockchain today, what is going on behind the scenes? One of the guides we looked at used a bus station analogy, and I think we need to walk through it.
The bus station analogy is fantastic because it makes an incredibly abstract mathematical process very concrete. Let's walk through it step by step.
Okay, say I want to send an asset to you. First is the initiation. I have two keys. I have a private key, which I should think of like my secret PI number, and a public key, which is like my bank account number or my public address. I use my private key to sign the transaction, proving I actually authorize it. Where does it go from there?
Once you authorize it, your transaction doesn't immediately go onto the blockchain. It goes into a digital waiting area called the mempool.
The mempool.
Yes. In our analogy, this is the bus station waiting room. Your transaction is sitting there with all the other passengers, the other pending transactions, waiting to get a seat on a bus. And while you're waiting, the network nodes act like the ticket officers.
Checking my ticket.
They check your credentials.
Yeah.
Did you use the right private key? Do you actually have the funds in your account to make this transfer? They independently verify the math.
Okay, so I'm verified. I'm sitting in the waiting room. So who are the bus drivers? I always hear the phrase mining and proof of work thrown around in the news. Is the miner the bus driver?
Yes, think of miners as the bus drivers. They pull a group of verified transactions from the waiting room and load them onto their bus, which represents a new block of data. But to officially depart the station and add this block to the chain, the bus driver has to do some work.
Thus, the phrase proof of work.
Exactly. To seal the block, the miner's computer has to solve an incredibly complex, resource-intensive mathematical puzzle. It takes a massive amount of computing power and electricity. The first miner to solve the puzzle gets to seal the block with a unique digital fingerprint called a hash.
Wait, let's pause there because this is where I usually get lost. What exactly is a hash, and why does a digital fingerprint make things so ridiculously secure?
Think of a hash as a mathematical blender. You can take any amount of data, a single word, or the entire text of the Harry Potter series, put it through this mathematical algorithm, and it spits out a fixed-length string of random letters and numbers. That's the hash.
Okay.
But here's the magic. If you change even one single comma in the original data and run it through the blender again, the resulting hash will be completely 100% different.
Oh, I see. So if someone tries to tamper with a transaction inside the block, the fingerprint completely changes.
Exactly. And here's where the chain and blockchain comes in. Every new block's hash includes the data from the previous block's hash. They are mathematically linked.
So what happens if a hacker tries to fake a block? Say they hack into a block from 3 years ago to give themselves more money.
It creates a domino effect. If they change one transaction in an old block, that block's hash instantly changes. Because the next block relied on that old hash, the next block is now invalid. And the next block, and every single block that follows it.
Breaks the whole chain.
Yes. To successfully hack the chain, you would have to recalculate the complex math puzzle for the altered block, and every subsequent block, faster than the rest of the entire legitimate network, is adding new blocks, all while controlling the majority of the network's computing power.
So it's practically impossible. It is an absolute fortress of digital security. But as we discussed earlier, this technology didn't stop with just moving digital money around. It has evolved significantly over the last decade.
If we connect this to the bigger picture, the evolution of blockchain actually mirrors the evolution of the internet itself.
Let's look at that parallel because it really grounds the concept. Think about the web. Web 1.0, back in the 90s, was the static web. It was read-only. You went to a website, you read an article, and that was it.
Very basic.
Then came Web 2.0, the social web. It was read-write. You could interact, post on Facebook, upload to YouTube. Users generated the content, but giant centralized tech companies owned all the platforms, the servers, and the data.
We all know how that turned out.
Right. Now we are entering Web 3.0, which is read, write, execute. It's decentralized. It's an internet where users actually own their data and their digital assets, largely powered by blockchain.
And just as the web evolved in tiers, blockchain has its own generational tiers. Blockchain 1.0 was that first era, from 2009 to roughly 2014. It was entirely focused on digital currency and decentralized money, primarily Bitcoin.
Just proving the concept worked.
Exactly. It solved the double spend problem and proved the underlying technology actually worked at scale. But then came Blockchain 2.0, and this was a massive leap forward. In 2014 and 2015, a new platform called Ethereum was launched. Ethereum took the basic distributed ledger concept but added something revolutionary, Smart contracts.
Okay, smart contracts. I was reading about these and it blew my mind. The simplest way to think about them is self-executing code. The terms of an agreement are written directly into the code, and when the predetermined conditions are met, the action triggers automatically. No lawyer needed, no middleman, no human intervention.
It's pure automation.
Think about travel insurance. Last year, my flight was canceled, and I spent 3 agonizing hours on hold with an airline listening to terrible elevator music just to get a $50 voucher. It was a nightmare.
We've all been there. It's a completely inefficient, centralized process.
Exactly, but imagine you buy a decentralized flight insurance policy using a smart contract. The contract is connected directly to a global flight database. The rule is written in code. If the flight is delayed by more than 2 hours, pay the customer.
Seamless.
If your flight gets delayed, the code automatically sees that data, triggers the contract, and the insurance payout is instantly deposited into your digital wallet while you are still sitting at the gate. You don't call a claims agent, you don't fill out a form, it is instant and guaranteed.
Which leads us right into Blockchain 3.0. This tier took those smart contracts and used them to build entire decentralized applications, or dApps. This era also focused heavily on fixing the problems of the earlier blockchains, namely slow transaction speeds and the massive energy consumption of that proof-of-work mining process we talked about earlier.
Right, the environmental concerns.
Exactly. So Blockchain 3.0 saw the rise of alternative consensus methods, the most popular being proof of stake.
Hang on. If proof of stake doesn't use the massive math puzzles and all that electricity to verify blocks, how do they agree on the next block? What's the stake part?
Instead of using computing power to prove your honesty, you use capital. In proof of stake, users lock up or stake a certain amount of their own cryptocurrency as a security deposit. The network randomly selects one of these stakeholders to validate the next block.
So they put their money where their mouth is.
Precisely. If they validate legitimate transactions, they earn a reward. If they try to cheat or approve fraudulent transactions, the network slashes their security deposit. They lose their money. It uses financial incentives to maintain network security rather than burning massive amounts of electricity.
That makes so much sense. It's a behavioral guarantee instead of a computational one. And the timeline doesn't stop there. We are now looking at blockchain 4.0 and 5.0. This is where blockchain starts integrating seamlessly with other cutting-edge tech like artificial intelligence and the Internet of Things, or IoT.
Exactly. We're moving toward a world of hyper-connected autonomous systems.
To make that concrete, imagine your house functioning like a decentralized microeconomy. Let's say you have solar panels on your roof. You go on vacation, and your panels are generating more electricity than your empty house needs.
Okay, I follow you.
Through a blockchain-integrated IoT system, your house could automatically detect that excess power, negotiate a price via an AI-driven smart contract, and sell that electricity to your neighbor's electric car charging in their driveway.
Without you doing a thing.
The payment happens instantly via a microtransaction on the blockchain. No power company acting as a middleman, no monthly billing statements, just devices talking to devices securely.
That is the ultimate vision of Web 3.0 and beyond. It's an entirely new infrastructure for how data and value move around the globe.
So what does this all mean? We've talked a lot about the theory, the history, the mechanics of hashes and nodes. But why should you, the listener, care about this right now? What are the real-world applications happening as we speak?
The applications are already transforming major industries behind the scenes. Let's look at supply chain management. When you go to the local grocery store and buy a bunch of bananas, how do you really know they were ethically sourced from a specific farm in South America?
Usually, I just have to blindly trust the little sticker on the peel.
Right. But with blockchain, that entire journey can be logged on an immutable ledger. The South American farm logs the harvest. The shipping company logs the container temperature during transit. The customs officials log the inspection.
So there's a permanent record.
Yes. By the time it reaches your store, you could theoretically scan a QR code and see the unalterable, transparent history of that exact batch of bananas, ensuring quality, safety, and authenticity at every single step.
That transparency is huge for the healthcare and pharmaceutical industries, too. I was reading about a project called Meta Ledger. They use blockchain to verify pharmaceutical products as they move through the supply chain. This is absolutely critical for combating counterfeit drugs, which is a massive, deadly global problem.
It really is.
There is also a huge push to use blockchain to secure electronic health records, or EHRs. Imagine if the data from your wearable fitness tracker could be securely encrypted on a blockchain, and you could grant temporary, highly secure access to your doctor during a visit without that sensitive data sitting permanently vulnerable on a hospital's centralized, hackable server.
We are also seeing incredible disruption in real estate and intellectual property.
Take a platform like Propy, which is optimizing property transactions. Buying a house traditionally involves mountains of paperwork, title searches, escrow agents, and a surprisingly high risk of wire fraud.
It's so tedious.
Extremely tedious. But blockchain streamlines that entire process using smart contracts to hold funds and transfer the deed automatically and securely the very second all conditions are met.
And for artists and musicians, the traditional music industry is notoriously slow. Instead of relying on record labels and streaming services to calculate and distribute royalties, which can take months and involves a lot of opaque accounting, musicians can release their music tied directly to a smart contract.
It changes the whole dynamic. Every single time a song is streamed or used in a video, the smart contract automatically and instantly triggers a micro royalty payment directly to the artist's digital wallet. It completely democratizes how creators get paid and removes the predatory middlemen.
It is truly staggering to step back and look at the journey this technology has taken.
It really is. We started today by looking at a couple of cryptographers in 1995 publishing strings of text in the classified section of the New York Times. And from that simple desire to verify digital documents, we've walked through the invention of Bitcoin, the mechanics of miners and mempools, and the evolution into smart contracts, decentralized apps, and a future where our solar panels, healthcare records, and even the music we listen to are managed by trustless automated code. You have successfully navigated the blockchain deep dive.
But before we completely wrap up, I want to leave you with one final provocative concept. This raises a massive question about the future. Throughout this entire discussion, we have emphasized that blockchain security relies on incredibly complex cryptography and mathematical puzzles. It is virtually unbreakable today. Changing a hash is currently impossible. But what happens when computing power takes its next massive leap forward?
Oh, you're talking about quantum computers.
Precisely. We are rapidly approaching the era of quantum computing, where machines will be exponentially more powerful than anything we have today. They solve problems differently than classical computers. The provocative question is, could the unbreakable encryption that secures all the world's blockchains eventually be cracked by a quantum computer?
That's a terrifying thought.
If a machine can solve those cryptographic puzzles and recalculate hashes in milliseconds, the immutable ledger suddenly becomes vulnerable.
That sounds like a sci-fi thriller scenario. The ultimate digital codebreakers going up against the ultimate secure realm.
It's a very real concern for cryptographers worldwide. In fact, developers working on blockchain 4.0 and beyond are already racing to build quantum-resistant algorithms. They are trying to future-proof the technology before quantum computers become widely available and weaponized. But it leads us to something profound to ponder. Will the ultimate immutable ledger survive the next massive leap in computing power, or will our entire concept of digital trust have to evolve all over again?
That is a brilliant thought to mull over and a perfect place to leave it. Thank you so much for joining us on this deep dive. We hope you feel a little more well-informed, a little less overwhelmed by the jargon, and inspired to keep exploring the incredible world of decentralized technology. Keep questioning, keep learning, and we'll catch you on the next deep dive.